Thank you very much. If everyone can hear us, then good morning, everyone. Good afternoon, good evening, if you are in other regions of the world. Welcome to Unit 2 of the course of Fiscal Toolkit. And on behalf of my colleagues, Eduardo Ortiz, Alberto, and Maria Jose, who just joined us as a part of the teachers team in this course. Welcome you all to the unit of general characteristics of fiscal and microemulation model. This is actually the first unit in which we are to go a little bit more deep into the micro simulation process. So from last week, retaken from last week, we were speaking about sustainable development goals, the 2030 agenda, and how I think Ivan Rueda, I think your mic is still open. Thank you. Right. And then we were talking about the financing instruments of how one of the biggest challenge of this SDG agenda was to finance the development all over the world. And we were talking about how there, while on the MDGs we had, it was basically founded on ODA. For the SDGs, we have a diversity of sources of financing. We have a public and domestic, public and international, and we also have private and domestic and private international sources of finance. Basically, the fiscal toolkit goes into the square of public and domestic sources of financing for development. And we were also talking about how this the fiscal toolkit can help us to generate revenues, to realign expenditures, to avoid future better our policies, right? So what is the fiscal toolkit about? What are the questions that help us answer? So for example, we have the fiscal toolkit is a diagnostic and evaluation tool to reduce poverty and social and economic inequalities. And to do that, we assess the different policies from taxes and expenditures and subsidies, etc. And three of the questions that we could answer with the tool like this one is: how much does the market and the state contribute to inequality, for example? How progressive or regressive certain policy is? And what are the alternative scenarios for change? If we move from status quo, what would happen if we have a new policy, a new tax policy, for example, or a new subsidy, or a conditional cash transfer program?
Sí, ya está acá.
Virtual campus, your mic is open. to say something? All right, thank you. So this is, so let me explain a little bit how do we get there to answer these questions. And most of it starts from certain definitions of income. We're going to define income in different ways. And with those different definitions of income, we are going to estimate, for example, the Gini coefficient to see if the Gini coefficient is going up or down. At the end of this session, I'm also going to speak a little bit more about the Gini coefficient and its relation to the Lorenz curve to see how the intuition behind this coefficient. So to start with the definitions, we have market income. And market income is basically the gross income people earn. That is before taxes, before paying taxes, before receiving subsidies. It's basically what people, the most gross income one can have. And you're going to see the definition in the document for this unit. But basically, it includes different sources, not only salaries, for example. You could also have remittances as part of the market income, because the idea is to separate what the people's earnings from market from state intervention. So it's before state intervention, before any kind of state intervention. Then we have direct taxes and employee contributions to Social Security. And once we deduct that, we have net market income. Okay, so for example, IRS is a tax, a direct tax on people's earnings. And once we have also direct transfers, positive transfers from state to the individuals, then we have disposable income. And if we add and subtract indirect subsidies and indirect taxes, then we have post-fiscal income. One example of indirect tax is VTA, value-added tax, but also could be sales tax or any tax that is directed to consumption, to tax some sort of consumption. Then we also have in-kind transfers from state. For example, public expenditure on public education or government expenditure on public health services that are free for the population, or maybe not free, but highly subsidized. Those are transfers in kind from state to the individuals. That would be our final income. All right. So what do we do with these definitions? Well, I'm going to do a very short parenthesis, because Fiscal Toolkit, the microsimulation process, is based pretty much on what Nora Lustig has done with her project Commitment to Equity, led from University of Tulane. And there are publicly available papers from this Commitment to Equity. If you can Google your country and Commitment to Equity, I'm sure you will find probably most likely you will find a paper about your country. So, for example, we have here one of the papers from Nora Lustig, the 5 countries: Brazil, Bolivia, Costa Rica, El Salvador, and Guatemala. And we have in columns different, the different definitions: market income, net market income, disposable income, post-fiscal income, final income, and then the differences between disposable and market income and final versus market income. And we can see now the Gini coefficient. The numbers that we see in the tables are the Gini coefficients for different definitions of income. We can see in Brazil, in the case of Brazil, for example, that if we compare the Gini coefficient for market income and the Gini coefficient from final income, that the Gini coefficient is reduced by not 14 points. And there is a considerable reduction in inequality in Brazil through the state intervention taxes and subsidies and transfers in kind, etc. And we can see the case of Guatemala, which is not that progressive. I mean, the fiscal policy in Guatemala does not have an effect that reduces the Gini coefficient that much. Only not 0.024, as you can see. We have in this slide the case of Uruguay, also based on one of the papers by Nora Lustig. And in the columns, we also have the definitions of income that we mentioned before. And on the rows, we have the Gini coefficient, and the different poverty lines, poverty headcounts for different poverty lines. And as one of the things to know is that the direct taxes and transfers has a moderate progressive effect in Uruguay. As you can see, the Gini coefficient goes from 0.49 to 0.45. But then when we consider the transference in kind through, for example, health or education, which are very strong in Uruguay, then you can see that the Gini coefficient for final income reduces to 0.39. That is almost 10 points of Gini coefficient. And then we can also see changes in terms of the poverty headcount. And for the disposable income after direct transfers and taxes, the poverty line for $2.5 per person per day, it's only 1.5%. Uruguay is one of the countries that is going to eradicate poverty very soon. And today is the International Day of Poverty Eradication, by the way. So congratulations to everyone who is working on that. But when we see the post-fiscal income that considers also indirect taxes, like VAT, for example, then the poverty headcount in Uruguay increases to 2.6%. That means that indirect taxes in Uruguay have a regressive effect that increase poverty. All right. In this slide, we can see also some of the things that the Commitment to Equity can do in their papers. And there you have a list of programs or expenditure areas from the government, also in Uruguay. And as you can see, those that it goes expands to expand to the left right hand side are those reducing inequality, that the Gini coefficient is reduced by these curves. And those that go to the right hand side are regressing. The Gini coefficient is increasing. All right, so at the top of the table we see food vouchers, food baskets, family allowances, and contributory pensions. All those are very progressive policies. Those reduce inequality. They have improved education policies, theory education, and we also have some policies that do not have a big effect, then those with regressive effect. And it is important to see that while tertiary education is not progress, increases the Gini coefficient. This is related to school dropouts at high school level. And the rationale behind that is that for the poor, it is very expensive to go to university, to go to college, and not because the fees are expensive or the books or whatever. Is the opportunity cost of that. Usually, poor people need to start working very young, very early, and they need to leave studying soon. So reaching university level is very expensive for them in those terms. So this doesn't mean that that we should avoid or we should cancel any public spending on tertiary education, subsidizing universities. I don't want to say that, and I don't want you to understand that from this graph. It's just that public university may have some other goals as producing public knowledge, public goods for the society that is not reflected here in the Gini coefficient. And so I just made some other point. We can debate about the usefulness of other policies, but I want to move to the microsimulation exercise. So what we saw before in the graphs is what Commitment to Equity does in several countries. So what do we do with the microsimulation? And the typical example, flagship example from microsimulation is the Mexican one. At the beginning of President Enrique Peña Nieto's administration in 2013, he was about to submit to the Congress fiscal reform, and the most polemic element of this reform was VAT, a generalized VAT that would include food and medicines. And before the reform in Mexico, food and medicines were exempt from VAT. So it was a very controversial initiative. So at the moment, what UNDP did with the Ministry of Social Development, at that time I was working for the Ministry of Social Development, and I was on the other side of the project. And Eduardo Ortiz and Roberto Castaño were the leading team from UNDP's side. We are lucky to have them both as part of the teachers in this course. So what happened in Mexico? We did a microsimulation exercise to see what would happen, and the result, as a matter of fact, the microsimulation estimated that revenue from this change in the policy would increase 3.75% of GDP, which is huge. It's a huge increase. But then food poverty, the lowest income poverty estimated in Mexico, would increase in 14.5 million people to 32.1%. So it was a huge increment in increase in the poverty rate, and that was very expensive for the country, for Mexico to have 14.5 million people more under the food poverty line. And it was also very expensive, politically speaking, for a president that was just about to start his presidency. And I'm sure other aspects played as well, but actually one very important piece of information was this, the microsimulation exercise that we did in Mexico. And at the end, when the president submitted, a couple of weeks after we finished the microsimulation, the president submitted a fiscal reform without including food and medicine in the VAT. So it was a huge success for the country, for those involved, and we were really happy, everyone involved in this project. Really happy. Let me just go very quickly then to the objectives of this unit 2 of the physical toolkit course. And we have three objectives. One is that you can recognize the main characteristics of microsimulation models, and to identify also the different kinds of microsimulation models, and also to know a little bit more, to understand the basic intuition behind the Gini coefficient and the Lorentz function. Since we are going to speak a lot about Gini coefficient, it's important for you to know at least the basics. For those taking the advanced track, at some point you will have to do a little bit more than just knowing the basic, but don't worry too much at this stage. It's not going to be that complicated, I promise. So, basically, the main characteristics, we already spoke about the income definitions and how these definitions based on these definitions, we can estimate Gini coefficients and poverty rates and see what are the distributional effects of certain policies. I'm not going to repeat the definitions. But then one thing that is important for you to know is the different types of microsimulation models. So let me go very quickly on this diagram. Yes. Charles, you want to say something? No. All right. Then first we have coverage models, and then in these coverage models we have two types: integrated models that are simultaneous estimation of various quality, and specific models that simulates only part of the policies. Then we have time frame models that in this case we have first static models and dynamic models. As you can imagine, static models are for on one moment in time, and dynamic try to see the effects of certain policies for a certain period. Then behavior models, and in this case we have models, non-behavior models, that are those who assume that changes in policies do not change consumer or people's behavior, for example, in terms of their preferences, and behavior models that try to model also how changes in policies also have an effect on the preferences of people. Then spatial models, in addition to the typical country level examples, we could have regional models if we have enough data for that, but we could also run microsimulations for a set of countries if we have data for that. And then usage models, that is models that allow certain flexibilities or accessibility for the user. All right. What are then the advantages and disadvantages of microsimulation models? One is simplicity, and maybe at this stage you think, oh no, microsimulation models and physical toolkit all sounds really, really complex and complicated, and it is not simple at all. Very soon you will find out that it's very, very simple. For those who took the top risk course, you will see that we don't need risk data. We don't need a Stata to run the microsimulation estimations. Most of the time it's done in Excel, and it's basically in Excel because almost everyone has Excel license. Stata is not that easy to get, and because almost everyone knows a little bit of Excel, and Stata is harder to handle. And we don't need very complex regression methods or things like that. It's really, really, really simple. You will very soon see what we are talking about. Then another advantage is that we can capture the heterogeneity of individuals, because we use micro data of household surveys, and as you will see, microdata, what we mean by that is that we use the database at household or individual level. So we don't use average of surveys. We use microdata. And that allow us to capture this heterogeneity of individuals. It also allows us to obtain representative results for the population, but also for target populations. For example, if we want to see a certain group of individuals working in a certain industry, if the data allow us to do that, we need to check on sample sizes of those things, because probably we want to do a very specific analysis of a certain industry in certain region, and maybe the sample is not big enough to do some to infer about the results for that subgroup. The microsimulation also let us model changes on rules, on taxes, on road taxes, or changing or see different hypotheses for eligibility criteria for social programs, for example. And we can also see who are losers and the winners of certain policy changes. The disadvantages are also important. The quality of our microsimulation will depend on the quality of the information contained in the microdata. So, right? Sometimes information is fragmented or dispersed. That is, for example, sometimes we don't have a survey with the income and expenditures, household income and expenditure. We have a yearly income survey, but the expenditure survey is every 5 years, for example, with different periodicity or different sample sizes. And sometimes information that we want to model in our microsimulation is not captured in the questionnaire, and if it's not in the questionnaire, it's not in the dataset, then we need to get it from somewhere else, and then we need to make some assumptions. Microsimulators have specific objectives. So a very important piece of the puzzle is to have clarity on what one to simulate. For example, in the case of Mexico that we just mentioned before, we saw that it was about VAT, the most controversial part of the policy. But it was also, part of it was also for direct taxes, for income tax. And in the case of Mexico, we had two different simulators, one for VAT and one for income tax. And that means that if we model something in a country, and then we won't be able to answer all the questions. We will be able to answer the questions that we want to model with that we stated at the beginning of the microsimulation process, to see how certain policy changes. But then if we want to see something else, certain other kinds of taxes or conditional cash transfers or whatever, then we need to simulate it. And that means also that microsimulation models are partial equilibrium models, not general equilibrium models. And that is important because even though we are talking about Gini coefficients and Lorentz curves and etc., all that is microeconomics. We are not talking about macroeconomics. So it's not suitable for macroeconomic influences. And finally, the assumptions, something that I mentioned already at the beginning of the disadvantages, is that the quality of our model will also depend on the quality of our assumptions when we gather information from different sources, for example. Then let's move very quickly, because I think we are running out of time, and very quickly on the Gini coefficient and the Lorenz curve. So what is the intuition? Probably some of you already know about the Lorenz curve and the Gini coefficient, but for those who don't, let me go very quickly on this. Let's assume that we order people from the lowest to the highest income, and then we have a proportion of that in terms of the population. The Lorenz curve is that cumulative proportion of the population and the income. So on the vertical axis, we have the proportion, cumulative proportion of total income in a society or in an economy. And then on the horizontal axis, we have the cumulative proportion of the population. So it goes from 0 to 1 on the horizontal axis and from 0 to 1 on the income axis. So what happens in a hypothetical society where everyone has the same income? In that case, the cumulative proportion would be this line that is called the equidistribution line, that goes from 0, 0 to 1, 1, from the lower left-hand side corner to the upper right-hand side corner. That is the equidistribution line. And the Lorenz curve goes below that equidistribution line. And how below, it depends on how unequal is the income distribution. So let's assume at some point that in an economy, only one person has 100% of total income. And in that case, what would happen? What would be the Lorenz curve like? In that case, it would be a line that goes through the horizontal axis, because everyone has 0, except the last one. And then the last one, in there, the Lorenz curve will jump as a vertical line to the top. It would be some sort of a mirrored L-shaped curve. And those would be the extreme scenarios. Virtual campus, do you want to say something?
No, I want to.
All right, thank you. So if a Lorenz curve is closer to the equidistribution line, then it's more equal. And if it's closer to the lower right-hand side point, then it's more unequal. And when the Lorenz curve crosses, then it would be harder to know which income distribution is more equal than the other. But we have the Gini coefficient. The Gini coefficient tries to summarize in a number what is represented in a graph in the Lorenz curve. And it's very helpful because we can solve the problem of crossing Lorenz curves. So you can see the formula for the Gini coefficient. Don't worry about that. Only those in the advanced track will need to be to study that formula later. But it's really simple. You will see it in text in the document too. But I want to explain a little bit what is the intuition behind the Gini coefficient and its relation to the Lorentz curve. The Gini coefficient is we have two areas. One, let's say area A is this sort of would be like a watermelon slice that is on diagonal. That area, we call it area A, and it's basically the difference between the equidistribution line and the Lorentz curve. And then we have this triangle, that is the triangle formed by the equidistribution line and the horizontal and vertical axis. And Gini coefficient is A over B. Is that easy? And I can tell you at this very moment, for every income distribution, what is going to be the value of B? Because if B is a triangle, and the area of a triangle is estimated by base times height over 2, right? And we know exactly that the base and the height of the triangle is 1 and 1 over 2. The B is equal to 0.5. That was very, very easy. The difficult part is in estimating the area of A. But what happens when we have equal society, an equal income? In that case, the area of B would be 0, because the Lorentz curve would be the equidistribution line. And the Gini coefficient would be then 0 over 0.5, and that is 0. We know that the Gini coefficient goes from 0 to 1, and it's 0 if there is no inequality, and it's 1 if we have total inequality. So how do we estimate Gini coefficient with total inequality? We already said the Lorentz curve would be a mirrored L-shaped curve, right? That would be on the axis. So that the area below or between the Lorentz curve and the equidistribution line would be exactly the triangle that we draw for B. That is 0.5. A would be also 0.5, and 0.5 over 0.5 would be 1. And there you go. You have the intuition behind the Gini coefficient and its relation to the Lorentz curve. And I want to stop here because I think I want to leave some minutes for questions and comments from everyone. So I don't know if you have any question. Eduardo, if you want to say something.
No, Ivan, not at this moment. Probably in a bit, if there are some specific questions, then I can add something. But at this moment, no. Thank you. It's a great presentation, actually.
Thank you. You are my friend, and I wouldn't expect anything else, anything different from you. Thank you. So, any questions from the students in our room? Let me see. I don't see any question in the chat room.
No, there are no questions. Maybe we can elaborate a little bit on based on the previous questions and comments, the most common questions that emerge, maybe we can elaborate on that.
Sure.
It could be useful. Well, there's a question here.
Thank you.
This Andres Chiverrera. I would like to know if there will be some unit in which the indicators for the SDGs under construction would be. I lost the question. Will be discussed or mentioned. I found a page where they are listed there. For every country. Okay, maybe we can. Okay, Ivan, I don't know if you want to start or I can start.
Go ahead.
Yeah. Okay. Javier Muñoz Blanco. Are there rules or taxes that behave the same way all the time for all the countries? Thank you, Javier, for this question. No, I mean, in terms of the effects on inequality or how unequal are some fiscal interventions, you can observe some tendencies across countries. In our experience, specifically in Latin America, which is that most of the indirect taxes, the VAT or the sale taxes, exert a negative effect on the distribution, right? And you can expect that because of their design. And so in that regard, yes, you expect that the same way that you expect that some direct taxes exert a positive effect on distribution of income because of the design. What distinguish the effects across countries is it's how taxes and benefits are targeted, right? For instance, even though an indirect tax could be harmful for inequality purposes in, I don't know, in Mexico, to name a country, it could be the case that negative effect be counteracted by a very efficient and a well target transfer, right? So the negative effect it's counteracted by transfer, the positive transfers. Or you can have another case, which they exist, where even though you have a very progressive transfer, potentially or an apparently well-targeted transfer, that positive effect, it's negatively counteracted by a very regressive tax. So it depends on how you target the fiscal interventions, how you treat your specific populations. But if we talk about an average, yes, you can expect some sort of obvious results like the ones that I previously mentioned. But there are some variations, and because of that variations, this type of exercises exist, right? To correct some those discrepancies, to try to do a better intervention both in terms of transfers, in terms of who burden the taxes, etc., etc. I don't know if Ivan, if you want to add something or.
Yes, thank you, Eduardo. Instead, I would like to try to answer some of the the other questions. Andres
That's
Chile
great.
Herrera from Bolivia, he was asking about the SDG indicators, and that he found a web page. Well, the thing is, the SDG indicators are not standard for all the countries. We actually have this definition of 3 tiers of SDG indicators. Tier 1 are those indicators that we have the data and that we can measure the indicator, and those are available for most countries, tier 1 indicators. Then tier 2 indicators are those for there's data in certain countries and maybe not in others, and but then we could also work on generating the data, or maybe we have the data but we don't have the indicator, and maybe we can estimate the indicator. So tier 2 indicators in the SDGs are more or less doable, right? And then tier 3 indicators are those indicators for which we don't have data, and we don't have indicator, and so we need to first to see how we are going to collect data, and then how the indicator is going to be estimated. So the availability of what indicators are available for each country depends or varies from country to country. And I'm happy that you found a web page, and it would be great if you can share in the forums the web page with the rest in the course. There was also a question on the MPI, the multidimensional poverty measures, and since most of the microsimulation is done based on definitions of income, then we measure income inequality and income poverty. That's the, let's say, the standard on microsimulation. But it is possible to simulate changes in multidimensional poverty, obviously with certain assumptions. As you know, multidimensional poverty measures, some of them take into account income, but most of them don't. So you could simulate, for example, changes in certain provision of basic services that are in the multidimensional measure, if they are, and then with the microsimulation you could see how certain intervention to provide some certain service, multidimensional poverty would reduce. This is not the standard. This would require a little bit more work and thought, but I don't want to say that it's impossible. Eduardo, anything else to add, or any other question?
No, from my side, not at this moment. No, apparently there are no more questions.
There are no more questions. Well, in that case, I think that we are going to finish on time, over the hour, and maybe it's time to start saying goodbye from this session. But please, if you have a question and you couldn't formulate it or have a comment and you want to express it later, please go to the forums and share your thoughts, your questions with everyone. if we don't have any more questions, then I hope you all a very nice rest of the week, and we'll see you next week. Eduardo, will you want to say something?
No. Thank you. Nothing more than thank you for the interest, and yes, please, if you have any comments, any specific comments, questions, please don't hesitate to drop us a line, and we will be in touch as soon as we can. Thank you very much.
All right. Well, in that case, see you soon. Bye-bye.